Right, so jumping straight on to, just take a look, 18.1 question 2. I'll do as many as these I can fit on there. Right, now look, I trust you've learnt sine, cos and tan, the rules for that. So it says here, copy these diagrams. I'm not going to do that because they're in front of me. Calculate the length marked x and give your answers correct to 1 dp. Alright, length x. Okay, 40 is given to me, so therefore the x must be opposite the 40 because it is opposite the 40. I've got the opposite, so that's the op, and I've got the side next to the angle, so that's the adj. Now look, what rule do we use? I've got op and adj, therefore I must use tangent. Alright, so tan for that one. Watch how I demo this then for question A. Now the tangent of 40 degrees is the opposite side, remember, x, which is the op, divided by the adjacent side, which is 6. So how do you get x on its own? Very simple. Take the 6 over and multiply. So x is going to be 6 lots of tangent of 40 degrees, or 6 times tan 40. But the calculator can handle that. So now we'll do it right now. So 6 tan 40 equals, so straight away I don't need to know what the tangent of 40 degrees is. My calculator knows. Look, I just put it in the calculator like that, and I let him work it out. I've got 5.03, so to one decimal place I've got 5.0, and it's in centimeters. First question done. Let's just do B here. What have I got here? I've got an angle, and I've got the angle, I've got the length x, which is opposite the angle, so that's definitely the op, so I'm going to put op there, and this is the longest side opposite the right angle, so this must be the hype. Alright, so 9 is the hypotenuse. I've got op and hype is sine. So I've got the angle, so the sine of 46 degrees, not the tangent, not the cosine, but the sine. How is it defined? It's defined as the opposite length, which is x, divided by the hypotenuse length, the biggest one, which happens to be 9 centimeters. How do you get x on its own? Take the 9 over and multiply. So x is going to be 9 times the sine of 46 degrees. Again, I don't need to know what the sine of 46 degrees. I'll let the calculator do it. So 9 sine 46. Okay, so I've put in. I'm going to press equals. Bam. There's your answer. 6.47, so I'm going to call that 6.5 centimeters. Easy peasy, grade B. Let's just do C, shall we? What's this one all about? Oh, there's 41. The opposite is blank, but they don't want me to work out the opposite anyway. Look, they want me to work out mystery x, which is next to the angle 41, so that's the adjacent. And the longest side opposite the 90-degree angle is called the hypotenuse. I've got adj and hype. Therefore, the rule is cos. And I've got the angle for myself, for me, so the cosine of 41 degrees is defined as the adjacent length, which is mystery value x, divided by the hypotenuse, the biggest length, that's 7.5. How do you get x on its own? Take the 7.5 over and multiply. So x equals 7.5 times the cosine of 41 degrees, and here's my answer coming up. So 7.5 cos 41. Bam. Answer 5.66, 5.7. So my answer is 5.7 centimeters. Please note, I don't have to put times between the 7.5 and the cos. The calculator understands we're playing with algebra. We don't need to put a times there. Let's just do D. Try and make it fit up here, I think. If I put D here, a bit faint. Anyway, what have I got here? I've got 37 degrees. X is in fact the opposite. And here the 10.7 is next to the angle, so that's the adjacent. So I've got op and adj, that's called tangent again. So here I go. The tangent of 37 degrees is defined as the opposite length, which is x, divided by the adjacent length, which is given to us as 10.7. So how do you get x on its own? You take your 10.7 over to the other side and multiply. So I've got 10.7 times the tangent of 37 degrees, punch it into my calculator, and it won't make a mistake provided I press the right buttons. So 10.7, and it's tan 37 degrees, and that gives me 8.06, best known as 8.1 centimeters to one decimal place. D is done. Let's just do E as well. In this dark space here. Right, I want to know x. X is opposite the 65, so that's an op, and my hypotenuse is given to me there. It's opposite the 90, so it's the longest side. I've got Oppenhype, which is sine. So here I go. The sine of 65 degrees is defined as the opposite length, which is given a letter x, divided by the hypotenuse biggest length, which is given to us as 9.7. Get x on its own, take the 9.7 over and multiply. So it's 9.7 times the sine of 65 degrees. Pick up the machine with confidence. 9.7 sin 65. Bam. 8.79. There it is. Call it 8.8 centimeters, and we're laughing. And may as well do the last one because I've got time and space. Now it's all a bit upside down this, so don't cry about it. I'll try and make it fit here, and hopefully my face won't be in the way of it too much. Right, there's the 72, there's the opposite length. It's not given to us. They want the side next to the 72, so that's the adjacent then, isn't it? Okay, next to the 72, and this is the big one, the hype, the longest side opposite the 90-degree angle. So what I've got here, I've got adjacent and hype. Well, that's cosine, isn't it? So the cosine of the angle 72 is defined as the adjacent length, which we don't know yet, so it's x, over the hypotenuse length, biggest, which is given to us as 14.7. And to get x on its own, take the 14.7 over and multiply. So x equals 14.7 centimeters multiplied by the cosine of angle 72 degrees. Punch it into the machine with absolute confidence, and you will get the right answer. The machines won't lie. Times the cosine of 72, and there it is before I press the equals. There's the equals. I don't know what it is. Can you read it? Yep, 4.5 centimeters. I know that's correct. Can't argue with it. 4.5 centimeters. Not sure I've got time to do question 3 though. I just want to keep it all short and introductory and that sort of thing. Yeah, I might just do some of question 3 in the next video, but I won't do all of them necessarily. So I'm going to do some standalone questions. So that's a good intro. We've done what we've got. We've got 2 tans. Let's have a look. We've got a tan there. Where's my pen? Got a tan there and a tan there. I've got a sine there and a sine there and a cosine. Yeah, I've got 2 of each, so it's great question to start with. That was page 269, 18.1, calculating the side of a right angled triangle, and we're using trigonometry. That's that, and I'll catch you later very, very soon.